Today, we are diving deep into a question that honestly sounds like it's straight out of science fiction. How can something like pure mathematics write a poem? We're going to be looking at an incredible paper called Language as Mathematical Structure, which puts forward a pretty radical new answer. And it's one that might just change everything we think we know about language, meaning, and the AI that is literally reshaping our world.
All right, let's jump right into this. It's a real mystery. You've got these AIs, these large language models, or LLMs, right? And they can create beautiful writing, poetry, even computer code, using, well, nothing but math. But here's the thing. For decades, our best thinkers have told us that this should be completely impossible, that you just can't separate meaning from real human experience. And that contradiction, that's exactly what we're going to unpack today.
So here's the paradox, laid out plain and simple. How can an AI that has never felt joy or sadness, never had a single conversation, never even really existed in the world, how can it master language? All our big theories have told us that meaning is born from our experiences, from our interactions with each other. This whole thing, it's a puzzle that challenges just about everything we thought we knew for sure.
Now, to really get a sense of just how wild this AI revolution is, we first have to understand the two huge ideas that have pretty much dominated how we've thought about language for the past century. So let's meet the two titans who really defined this whole debate.
First up, you've got Ludwig Wittgenstein. His whole idea was that words are basically like tools. You know, a hammer is just a lump of metal and wood until you actually use it to build something. For Wittgenstein, language was the same. A word is meaningless on its own. It only gets its meaning, it only comes alive when we use it in these social situations he called language games.
Then, in the complete opposite corner, you have Noam Chomsky, and he had a totally different take. For him, language wasn't social, it was biological. He argued that all of us are born with this thing called a universal grammar, like a deep, almost mathematical rule book for language that's just hardwired right into our brains from day one. Look, both of these theories are absolutely brilliant. But here is the massive problem. An LLM doesn't have a social life, so it can't play any of Wittgenstein's language games. And it definitely wasn't born with Chomsky's universal grammar hardwired into a brain. It just doesn't have one. It works completely outside of these traditional ideas, which means, well, we need a new way of thinking about this.
And that is what brings us to this really groundbreaking paper by Dr. Dimitris Vartziotis. It gives us a third option. A totally new vision for what language might be. And it's a wild one. What if language isn't a social game or some innate program, but is actually something more like physics, like a physical structure with its own rules?
Okay, now this is where things get really incredible. Look at this timeline. Dr. Vartziotis published his theory of semantic fields way back in 2012. That's a full 5 years before the invention of the Transformer, the engine that makes all modern AI work. And what's just mind-blowing is that when this technology finally came out, it behaved exactly the way his theory predicted it would. It's just wild.
So this right here, this is the core idea that Vartziotis used to challenge Wittgenstein. He said language isn't just a game we play. No, it's a structure. It's like a field in physics. He imagines it as this kind of floating net, where every single word is giving off its own gravitational field of meaning.
So let's really lock in this definition because it's key. A lexical field is a word's personal bubble of meaning, its own little gravitational pull that it sends out into this space of concepts. So think about the word sun. Its lexical field pulls on ideas like heat, light, day, star. You get the idea. It's a field of influence.
And this just lays out the whole process perfectly. See, it's not about just adding up word definitions. First, every single word creates its own field. Then, when you put them together in a sentence, those fields all start interacting. They push and pull on each other. And this interaction creates a totally new, complex, combined field. And the final shape of that field, that's what our brain actually understands as meaning.
I know, this might all sound a little bit abstract, a little out there, but here's the kicker. It connects directly to how these AIs actually work under the hood. So how does this idea of fields actually show up in the code inside something like ChatGPT? Well, the answer is pretty startling. It turns out that the core engine of a modern LLM, the Transformer, is basically a machine built to calculate these semantic field interactions. The whole magic trick, this thing called the attention mechanism, works in a way that is an almost perfect mirror of Vartziotis' theory.
Just look at this comparison. It's an incredible one-to-one match. In the theory, words project fields that interact with each other. In the AI, every word is a vector, a mathematical object, and it attends to other words by calculating these interaction scores. In both cases, the final result is a brand new contextual meaning that's built from all these interactions. The AI, it's literally calculating the physics of language. And remember that metaphor? Vartziotis talked about words buzzing around each other, or colliding and changing their meaning. Well, that's exactly what scientists see when they visualize what's happening inside an AI's attention mechanism. They actually see these computational patterns of words buzzing and colliding, just like the theory described years before.
Even those famous word algebra examples that blew everyone's mind a few years ago, they're the perfect evidence for this. The reason king minus man plus woman equals queen isn't magic. It's just vector math. It's a geometric operation. The AI is literally manipulating these semantic fields. It's taking the king field, subtracting the masculine part, and adding a feminine part, all while keeping the royalty field perfectly intact.
So what this is all pointing to is that language seems to have this deep, hidden mathematical structure that we're only just now beginning to see, all thanks to AI. So, what on earth does that mean for the future of AI, and maybe even for how we understand ourselves? Vartziotis has this really beautiful way of putting it. He says, the language we see and hear, the sentences and poems, that's the woven fabric, that's the geometry. But underneath it all, there is a hidden mechanism, an algebra, that's pulling all the strings. And these LLMs are the first things that have ever been able to manipulate that hidden algebra directly. He calls it the algebraic unconscious of language.
What's great is that this theory also gives us a kind of roadmap for where AI is going. Right now, most LLMs are at level 1, field detection. They're just really, really good at spotting statistical patterns. But the next steps are way more advanced. Actively navigating this whole space of meaning, and then, finally, achieving a global awareness of the entire field, which might just be the line we have to cross to get to what we'd call true understanding.
And that leaves us with one last, really big thought to chew on. If these AIs are uncovering this deep, elegant mathematical logic that's been hiding inside language all along, well, maybe it's not an artificial thing at all. Maybe what AI is really showing us is a reflection of the profound algebraic structure that's been hiding in plain sight within human language and maybe even the human mind this entire time.